Not all and compound inequalities are going to result in a three-part inequality like the previous example. For instance, here we have again something simple. We have 3 is less than x and x is greater than -2. So again, I'm going to go ahead and plot these on a number line. We have our two boundary values, -2 on the left, 3 on the right. I'll go ahead and do this first inequality in pink again. 3 is less than x. So our boundary here is 3, and x is everything above that. 3 is less than x, so that means 0, if we plug that in, something to the left of 3. 3 is less than 0. That is definitely not a true statement, so we're going to go ahead and look at the other side, maybe 10. 3 is less than 10. That is definitely a true statement, so we would go ahead and shade to the right. Just like before, we have a less than sign, so we want to go ahead and use a parentheses here, and it opens in the direction that we're shading. Likewise, I'm going to go ahead and graph x is greater than -2, so our boundary there is -2. X is greater than -2, so if you want to just identify it based on that, we're shading to the right. And again, we have a parentheses opening in the direction that we're shading. Now, because this is, again, an and inequality, we need to think of this as, when are both of these situations, when are both of these restrictions true? On the left-hand side, nothing's true, so that's out. In the middle, only the second inequality is true, whereas in the right side, both of the inequalities are true. This is true and that is true here. So that means that our final solution to this would only be this higher region, everything above 3. Okay, now, oh, that's what I forgot to do in the first one. So now what we need to do here is we need to represent this using a few different methods. One way to represent this is just as a simple inequality, which is x is greater than 3. Another way to represent this is something that uses the inequality called set builder notation, which I think you've seen in the earlier sections of 8.1. Set builder notation is writing a mathematical sentence using a bunch of symbols, right? So our brace that we're using here, both on the left and eventually on the right-hand side, that says the solution set of. We're using the variable here, x. This bar means such that, and then we plug in the inequality. X is greater than 3. So this whole thing means the solution set of x such that x is greater than 3. Another way, this is set builder notation. Another way to represent this is using interval notation, which is something I talked about earlier. Interval notation is taking either our brackets or parentheses on the outside, and what we're doing is we're writing sort of like the interval of our answer, our solution set. So we always look for our lowest boundary number and our highest boundary number. So here, solution set is everything greater than 3. So our lowest possible boundary is a 3. Our highest possible boundary keeps on going on and on and on forever and ever and ever, so that's going to be infinity, which is again that sideways 8. My weird sideways 8. Now, next to the 3 here, we have a parentheses because of the inequality symbol less than. So we're going to have a parentheses on our interval notation. And then when we look at our infinity, can we ever actually equal the value infinity? Yeah, the answer is no for that, right? Infinity is this number that continues on and on and on. So next to every infinity, whether it's a positive infinity or a negative infinity, we're always going to have a parentheses. So this again is called interval notation. You'll see this quite often. Just really quickly going back to the previous example, I forgot to represent this using interval notation. Now it's kind of nice because since we're given that three-part inequality there, we have our lower boundary, -5, our higher boundary of +2. Next to our -5, just like in our graph, we have parentheses, and next to our higher boundary, just like our graph, we have a bracket. And that would be our solution set for the previous problem. I completely forgot to do that. Again, interval notation.